NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. For millennia, humanity has gazed at the stars, and for decades, probes have ventured into the vastness of space. Yet, only 2 spacecraft with operational instruments have ever managed to break free from the domain of the Sun. On January 28, the Voyager 1 probe passed a symbolic mark, moving 25 billion kilometers away from Earth. This is evidenced by tracker data on NASA's website, which indicates the position and speed of the vehicle. Launched in 1977, the twin Voyager probes embarked on an extraordinary journey through the outer solar system. Both spacecraft navigated past Jupiter and Saturn, while Voyager 2 extended its path to include Uranus and Neptune. A rare celestial event unfolded in the late 1970s, an alignment of the outer planets, an occurrence that takes place only once every 175 years. This cosmic arrangement presented an unprecedented opportunity for exploration, allowing a single mission to visit multiple gas giants in one grand tour. Recognizing the significance of this moment, NASA launched the Voyager program. Voyager 1, though launched after its twin, quickly overtook Voyager 2 due to a faster trajectory, reaching speeds of 38,000 miles per hour compared to its counterparts' 34,360 miles per hour. Just 13 days after liftoff, it captured an extraordinary image of Earth and the Moon from 7.2 million miles away, an image that would become a symbol of humanity's first steps into the outer reaches of the solar system. By 1979, both probes had reached Jupiter, unveiling a world more dynamic and complex than ever imagined. For the first time, the faint rings encircling the gas giant were observed, along with 3 previously unknown moons. High-resolution images of its largest satellites revealed a stunning discovery. Ganymede, not Titan, held the title of the solar system's largest moon. The probes also sent back data that would revolutionize the understanding of Europa, exposing a surface of smooth ice etched with deep fractures. This finding laid the foundation for the theory of a hidden ocean beneath the frozen crust, a hypothesis that continues to shape the search for extraterrestrial life. Jupiter's Great Red Spot, a colossal storm larger than Earth, was finally seen in breathtaking detail. But the mission was only just beginning. Utilizing Jupiter's immense gravity to gain speed, both spacecraft continued onward, reaching Saturn in 1980 and 1981. This marked a turning point for the mission. Originally designed to last just 4 years, the Voyager program had been strategically planned to allow for potential exploration beyond Saturn. A critical choice was made. Voyager 1 would conduct a close flyby of Titan, the only moon in the solar system with a dense atmosphere. Even though this trajectory would prevent it from visiting any further planets, Voyager 2, on the other hand, was sent toward uncharted territory, venturing deeper into the solar system. Saturn's rings, previously thought to be broad and uniform, were revealed in intricate detail. The probes discovered that they consisted of hundreds of fine, complexly structured bands. Among Saturn's moons, Nemesis stood out, its surface dominated by the massive Herschel crater, making it eerily reminiscent of the Death Star from Star Wars. Titan, however, held an unexpected mystery. Its thick, hazy atmosphere obscured the surface from view, yet through careful analysis, scientists determined that its temperature hovered near the triple point of methane, where the compound could exist as a liquid, solid, and gas, much like water does on Earth. From this point, the paths of the twin explorers diverged forever. Saturn's gravity flung Voyager 1 onto a trajectory that propelled it at record-breaking speeds, making it the fastest spacecraft in history. Meanwhile, Voyager 2 pressed onward toward Uranus, reaching the ice giant in January 1986. Unlike Jupiter and Saturn, which are composed predominantly of hydrogen and helium, Uranus presented an entirely different composition. Beneath its outer atmosphere, an immense ocean of water, ammonia, methane, and hydrogen sulfide surrounded a dense core of rock and ice. Scientists would later classify planets like Uranus and Neptune as ice giants, distinct from the traditional gas giants. Surprisingly, Uranus also held the title of the coldest planet in the solar system, with temperatures plunging lower than those on Neptune. Voyager 2, having completed its mission at Uranus, set course for its final destination, Neptune. In August 1989, it became the first and only spacecraft to visit the 8th and most distant planet in the solar system. On August 25 of that year, it transmitted the first-ever close-up images of Neptune, marking the completion of its legendary grand tour. The planet appeared in striking shades of blue, though subsequent analysis revealed that its true color was closer to teal. While Voyager 2 ventured into the outer planets, Voyager 1 had a different fate. After its Saturn encounter, many of its instruments were deactivated, leaving only those necessary to study its surrounding environment. Yet, despite this limitation, it was destined to make history one more time. On February 14, 1990, from a staggering distance of 3.72 billion miles, it captured a now iconic image of Earth, a near speck in the vast darkness of space. This pale blue dot, just 0.12 pixels in size, would become one of the most profound and humbling images ever taken. Shortly after, the cameras on both probes were permanently shut down, leaving them to drift silently into the cosmic unknown. As the years passed, they continued their relentless outward journey, their aging instruments still collecting invaluable data despite diminishing power. Then, on December 16, 2004, Voyager 1 encountered a crucial boundary, the termination shock, marking the beginning of its slow passage into interstellar space. 3 years later, Voyager 2 followed. Since then, these lonely explorers have provided the only direct observations of a realm beyond the Sun's influence, a vast and mysterious region known as the heliosphere. The heliosphere, once thought to be a relatively simple boundary, has proven to be anything but. "We know now how little we know," remarks space physicist Merav Ofer of Boston University. "It's far more complex, far more dynamic than expected." Though the Sun is often perceived as a distant sphere of light, its true nature is much more turbulent, a seething mass of plasma and magnetic fields. It continuously sheds charged particles into space in the form of solar wind, an ever-flowing river of energy that shapes the space around it. The Sun's magnetic field travels alongside this wind, extending its reach far beyond the planets, forming and sculpting the heliosphere. Over an 11-year solar cycle, the intensity of this force fluctuates, causing the heliosphere to expand and contract in a rhythmic pulse. You see these dramatic 11-year bumps, mints and maxes, dips and peaks, throughout the entire heliosphere, explains Jamie Rankin, a space physicist at Princeton University and deputy project scientist for the Voyager mission. This ever-changing solar environment affects everything within its grasp, including the very data astronomers use to study the universe. Every one of our measurements to date, until the Voyagers crossed the heliopause, has been filtered through all the different layers of the Sun, Rankin points out. Beyond the heliosphere lies a place untouched by the Sun's influence, a cosmic frontier still largely unknown. As the Voyagers drift ever farther, their signals growing fainter with each passing year, they continue to whisper secrets of the universe, messages from the very edge of the solar system, sent back to a small blue planet where their journey began. As the twin Voyager spacecraft ventured toward the unknown, they encountered a series of cosmic frontiers. The first was the termination shock, a turbulent boundary billions of miles from the Sun where the solar wind, a stream of charged particles, began to decelerate dramatically. Beyond this point lay the heliosheath, a vast and chaotic region where solar material slowed further, sometimes reversing direction under the influence of interstellar forces. Pressing forward, the probes eventually reached the heliopause, the outermost limit of the Sun's influence, where the outward push of solar wind met the inward pressure of the interstellar medium in a delicate balance. For Voyager 1, the swifter of the two, the journey through these shifting boundaries took nearly 8 years, a testament to the sheer scale of the solar system's outermost reaches. In 2012, it became the first human-made object to cross into interstellar space, followed by Voyager 2 in 2018. This vast, uncharted domain stands in stark contrast to the solar bubble left behind, a quieter, yet still dynamic, filled with high-energy particles known as galactic cosmic rays and ancient dust shed by long-dead stars. Extending far behind, others propose a more complex form shaped by the intricate dance between the Sun's magnetic field and the interstellar medium, perhaps something resembling a croissant with two lobes curling behind the solar system. It could be something entirely different, a structure yet to be imagined. From Earth's vantage point, determining its exact shape is a formidable challenge, akin to a goldfish trying to map the contours of its bowl from within, unable to reach the boundaries. Yet, against the odds, two aging explorers have provided a rare glimpse beyond the solar bubble. The Voyager probes, initially launched as planetary scouts, became unintentional pioneers of the interstellar frontier. Their mission was never meant to extend this far. They were humanity's first eyes on Uranus and Neptune, capturing unprecedented views of these distant worlds. By 1989, their primary tasks were complete: but the spacecraft remained operational. Rather than letting them drift into silence, NASA made a bold decision: keep them running, even if that meant shutting down instruments no longer relevant without planetary targets. As the years passed, the Voyagers continued their relentless journey, pushing ever outward, silently drifting toward the limits of the known and into the vast unknown beyond. The search for the heliosphere's secrets has not been left to chance. In 2008, NASA launched the Interstellar Boundary Explorer (IBEX), a spacecraft that orbits Earth, detecting energetic neutral atoms streaming in from the far reaches of the solar system's boundary. By analyzing these particles, scientists can reconstruct glimpses of the vast and turbulent regions billions of miles away. One of IBEX's most striking discoveries was a mysterious ribbon of energetic neutral atoms stretching across the heliosheath. This feature, thought to be formed by particles bouncing in and out of the heliosphere, offers a tantalizing clue about the interactions between the solar wind and interstellar space. Yet, by sheer cosmic misfortune, neither of the Voyager probes passed directly through this enigmatic ribbon. Instead, they slipped past on either side, missing the opportunity to examine it up close. The absence of direct measurements from these pioneering spacecraft highlights the challenge of studying such an immense, ever-changing structure with only a handful of observation points. The Voyagers, though invaluable, provide data from only two narrow paths, much like taking a biopsy of a vast and complex organism. Without a full three-dimensional map, the true shape and nature of the outer heliosphere remain elusive, leaving much of this cosmic boundary shrouded in mystery. IBEX continues its mission well beyond its original timeline, providing an unprecedented look at how the heliosphere responds to the Sun's shifting activity over a full 11-year solar cycle. This long-term observation offers crucial insights into the evolving boundary between the solar system and interstellar space, but preparations are already underway for an even more advanced mission. The Interstellar Mapping and Acceleration Probe, IMAP, set for launch in the coming year, will build on IBEX's foundation with sharper resolution and expanded capabilities. In addition to tracking energetic neutral atoms, IMAP will analyze interstellar dust, tiny remnants of long-dead stars that drift into the solar system, carrying clues about the wider galaxy. While remote sensing missions like IBEX and IMAP piece together a broader picture, other spacecraft are poised to venture into the region directly. Among them is NASA's New Horizons, the probe that delivered humanity's first close-up views of Pluto in 2015 before continuing its journey to Arrokoth, an ancient relic of the early solar system. Now, it presses onward into the depths of space, following in the wake of the Voyagers. If its instruments endure the harsh conditions, it could become the third spacecraft to cross the heliopause, offering yet another window into the vast and mysterious realm beyond the Sun's influence. Across the vast emptiness of interstellar space, the Voyager probes continue their silent transmissions, relaying signals back to Earth with data on their locations and the status of their aging instruments. But in 2022, an unexpected anomaly disrupted this routine. At a staggering distance of 14.6 billion miles, Voyager 1 began transmitting erratic signals, sequences of zeros and the number 377, baffling scientists. This cryptic data hinted at either a critical revelation or a deep malfunction. It was soon determined to be the latter. A failure within the spacecraft's attitude control and maneuvering system had disrupted its ability to orient itself correctly, likely caused by prolonged exposure to cosmic radiation. Engineers at NASA devised an intricate solution, rerouting telemetry signals through an alternative onboard computer, successfully restoring control. Yet, Voyager 1's most harrowing challenge lay ahead. On November 14, 2023, it fell silent for 5 months. No signal was received, leaving mission control in uncertainty. The culprit was found to be a corrupted section of code embedded within one of its chips, rendering communication impossible. The only solution was a painstakingly delicate maneuver reallocating the corrupted code to an undamaged section of the probe's onboard memory. On April 18, 2024, the transmission was sent, but patience was required. At Voyager's immense distance, a one-way signal took 22.5 hours to arrive, with another 22.5 hours needed for a response. 2 days later, on April 20, the long-awaited reply arrived. The fix had worked, communication was re-established, and Voyager 1 was once again operational. These malfunctions serve as a reminder that the Voyager's time is nearing its end. NASA estimates that their scientific instruments may continue to function until 2025, after which a gradual shutdown will begin. As the decades-old power sources weaken, the spacecraft will eventually lose the ability to communicate, likely around the 50th anniversary of their launch. When that moment arrives, it will mark the final chapter of this extraordinary mission. Yet, their journey will not end. Even in silence, they will continue their voyage into the unknown, bearing witness to celestial phenomena that humanity will never hear about. Voyager 1, moving at approximately 3.5 astronomical units per year, where 1 astronomical unit is the average distance between Earth and the Sun, now drifts toward the constellation Ophiuchus. In the distant year 4272, nearly 38,200 years from now, it will pass within 1.7 light-years of a faint star in Ursa Minor, AC plus 793888. Meanwhile, its twin, Voyager 2, traveling at 3.1 astronomical units per year, is on a path that will bring it within 1.7 light-years of the red dwarf Ross 248 in the constellation Andromeda, a journey that will take roughly 40,000 years. At present, Voyager 1 has reached approximately 15.5 billion miles from Earth, while Voyager 2 trails at 12.4 billion miles. Despite crossing the heliopause, the boundary where the Sun's influence wanes, it is not entirely accurate to say the Voyagers have fully left the solar system. The Sun's gravitational reach extends far beyond the planets, enveloping a vast, mysterious region known as the Oort cloud. This hypothesized spherical shell of icy bodies, the birthplace of long-period comets, is thought to mark the true outermost boundary of the solar system. It is estimated that the Oort cloud stretches between 50,000 and 100,000 astronomical units from the Sun, a distance so immense that even light would take a year to traverse it. If these estimates hold true, Voyager 1 will require around 300 years to reach the inner edge of this vast frontier and perhaps another 30,000 years to pass through it completely. Only then will it at last escape the Sun's gravitational domain. Should these spacecraft ever be discovered by an extraterrestrial civilization, they carry messages from their creators, remnants of human existence encoded in a golden record. This gold-plated copper disc, meticulously crafted by a team of scientists, holds an array of sounds and images meant to serve as a time capsule of Earth. Nearly half of the recordings are music, spanning diverse cultures and epochs. There are also greetings in dozens of languages, messages from world leaders, the calls of whales, the rhythms of human heartbeats, and even the electrical signals of a human brain. Should alien beings one day retrieve these artifacts, they will have a wealth of information to decipher. But if the Voyagers are never found, they will continue their silent drift through the endless void, untouched by time. These twin emissaries, humanity's first interstellar travelers, will remain as symbols of an unyielding quest for knowledge. Even as they fade into the darkness, they serve as a testament to the curiosity and ambition of a species that once lived on a small, pale blue dot, reaching out to the cosmos in search of understanding. If you enjoyed this journey beyond the solar system, don't forget to like, subscribe, and hit the notification bell for more deep space discoveries. Until next time, keep looking up and never stop exploring.